Hello, my name is Jeff Rush, and this talk is a demonstration walkthrough of the IPython interactive shell. If you missed it, there is a prior presentation, 5 Minutes with Python and the Interactive Shell, IPython, that provides a features and benefits overview in a slideshow format. Enough slides though. Let's get to some code. Start up a shell here. Bring up the IPython interpreter. Alright, looks like the normal Python shell, but it's got some extra features. You can do the usual variable assignment, just to give us something to play with here. Okay, but we also have the tab completion. I can type in part of a variable name. It will offer me the choice when I hit the tab key, and I can have it finish it and print out the value. Now, IPython offers namespace management features. For example, I've defined these variables. I can type the who command, and it will list the variables that are available to me. Maybe I only know that it's an integer, so I want to see only the two value variables that are integers. But I also sometimes want to see the types and values, so it can be a little easier. So we have the whos command. See, it gives us much more detail here. And then there are times when you want to search by name, so we can say we want to find all the variables that are starting with message, or that start with message but are of type integer. So the psearch command is useful for that. We also have the store command, which lets us store into the profile the current value of the message flag. The profile is basically your startup configuration. It's your current directory, a file in your current directory usually. And so it's useful to be able to store your variables there. The next time you start your session, they're back again. And you can also store that variable into a separate file. To see what has been stored, we can enter the store command. And we have here an ABC macro that I have left defined from a previous session, and message flag is now there. Now the namespace can be cleared with the reset command. So we can see we have the who command that shows us the variables. We reset, make sure that we're sure we're going to do this. I say yep, and then we tap the who command, and the namespace is empty. And then I can tell it to please restore those things that were stored. Now, not all the variables were stored. And then I can say who, and message flag and the ABC macro are back again. And if I get tired of that, I can type store-z, which zeroes out all of the storage. So the next time I start my session, there won't be any values left lying around. One of the features of IPython also is the logging. At the moment, logging is not on. So I tell it that I wish to start logging, so that we can keep a record of this. We can see here it stores it in the current directory of IPython log.py. The log is stored as a Python source file. It will rotate across versions, so each time I start a session that I'm logging, it will give it a suffix of a number and bump it to the next one. And logging also lets you optionally log the output of your commands, or just what you type in. At the moment, I'm just logging the input. And you can put timestamps if you'd like. Okay. And during your session, you can say log on, which is not a user login, but rather turn on the log, which it's already on, or you can turn it off. So I'm going to leave it on here. Okay, these commands I've been entering are called magic commands. Basically, they are commands, named functions built into IPython. We can get a complete list of what is defined by typing the ls magic command. And we see here quite a few commands are available to us. We're going to be going through these, most of them. Magic commands can be typed with a % sign as the first character, or not. The difference is that if you have a variable that is the same as a magic command, you need to put the percent at the beginning of it to differentiate whether you're talking to the command or talking about the variable. To get information about these commands that are available, we can type the magic, notice not ls magic, but just magic, and it gives us a scrolling help about the commands. I'm not going to read them all here right now, but I'm just saying that help is available. And hit Q, so it takes you into your normal pager ability to look, move through pages or something. If you want to get help on a particular command, however, sort of like the ls magic, you can type a name of something and hit one question mark, which gives me a generic or a high-level view of the object. So ls magic, we can see here, is a magic function, and that it takes no significant arguments here and lists currently available magic functions. You can also type in double question mark to get more information. In this case, it shows us the source code for this magic command. For our own variables, like the message flag, if you recall, that I defined, it was an integer. So it tells us basically about the int initializer. It's more interesting with functions, as we'll see shortly. Okay, there's a few little other cosmetic commands that the shell provides you. So, for example, we have we can import the sys module. P is a short for print, so we can print the syspath. And as you know, syspath is a list of places that Python looks up the name of a module. It looks up a module given a name. It's also the page, which says print the object, syspath, the list, but this time run it through the pretty printer, so we get a different look here. We've also got an automatic parentheses function in IPython, in that, let's see, if we define a function, very simple there, and if we type in A34, with commas, you'll see here that it took the option here without the parentheses, added the parentheses for me, and called the function. It just saves you when you're rapidly typing in the interactive mode. It can make your life a little bit easier. If you want to use that. The other one it has is callables, to make it callables a little bit easier. So if we define x to take no arguments this time, so we're just calling it, and I want to call it, I just put /x, and it saves me the trouble of typing two parentheses. Small difference. When I was defining the function back up here with ABC, let me bring it back here. We now have x function with two arguments. It took them as integers there. There may be cases where you'd like to make them strings. However, you don't want to have to type the quotes around it. So we can type comma x 3, 4. And you'll notice here that it called it by first converting those arguments into strings and passing it down. That's it, not much. Those aren't a big difference. A slight detour here into the help subsystem. Now, this is not IPython, but IPython integrates with the PyDocs system. So we can ask for help on the sys module, and it brings us into the basically like a man page and shows you the information about this module. You can have a string you pass to it. In this case, I'm asking for help on the for keyword. And it will take me into the online documentation, Python docs, and explain to me. It's wrapping oddly here because I have the font cranked up largely so you guys can read it. On your system, it may look a little better. And it also can, you can put it in capital letters, and it will actually give you topics. But let's just go into the help. We say, what are the topics that are available? So we can actually ask it for basically tutorial or explanatory material about any of these topics independent of the module or variables. So we can say, explain to me functions. I don't understand functions. And it goes in here and tells you how to create them and how there are two kinds of them and such like that, which can be useful. And we can exit the help there. You just hit Q to exit that. But having the help available to you makes your life a lot easier as far as you don't need to keep the reference manuals at your hand. Another source of information, of course, is introspection into your environment. So let's import the regular expression module to have something to play with here. And suppose we were about to, wanted to do some regular expression, but we don't quite understand what the arguments are for the match function. So we can say, what is the definition here of the RE match? It takes a pattern in the string to apply against that pattern and some flags. Or maybe we want to see what the documentation is about this function. So we have the pdoc command, and it gives us basically the doc string for that. But we might want to have both together. So we want to do the pinfo. This is very similar to what we had. It gives us, what is this object? What is the base class? Is it in an interactive namespace, or is it inside a class or in module? Which file did it come from? And definition and doc string here. So it gives you a little more information. And another cool one is the source. Suppose we wanted to say, well, we'd really like to understand more about this function here. So let's pop up the source of it. So here we can see the match is basically calling an internal function compile and passing in the pattern and the flags. Not a lot of source, but it does show you the source, and you can use this on any object, your own functions and methods, to take a quick peek at the source without having to fire up an editor. And you can, of course, apply the double question mark operator to it, and you get basically the same as the pinfo. And just for completeness, let's take a look with the single question mark. And then we also say, well, maybe we understand the p-match, and we've seen the little piece of fragment it comes from, but I really need to see the context, like the underscore compile and maybe some other information in that file. So let's take a look here at the file that we're in, which RE match is defined. Takes us to the top of the regular expression file for this, the regular expression file. So we can actually page through the source and read the extensive doc string here, our module doc string, and go through the source. And saves. Let's just makes it easy. Okay. But suppose we also say, well, I really like looking at this in my editor, not just paging through it. I like to have all my keystrokes and nice editor features at my fingertips here. So, what if we tell it we want to edit a function? We don't know what file it's in. Maybe we just say, well, we want to edit this function. So we can do that, and here it brings up Emacs, my preferred editor. It positions the cursor on the match function and shows us the source. And I'm now in the editor, and of course I can't change this because I don't have write access to the Python standard library, but it does let me clip or cut and paste out of this into my own source files, or use any keystroke macros in Emacs that I might have tag searches and things. So let's edit the editor here. But as you see, you can between the help and the introspection features, we can get a lot of information without having to go very far. Another function is directory navigation. It's an example. Where are we? We're in the home directory of the presenter account here. We can change directory. So we can go to the temp directory here. It's over there. And if we didn't know that, we could type in part of it and hit tab completion. So tab complete applies not just to variables and arguments, but also applies to directories. So we can change to that one. It also has the, if you're familiar with the bash shell, it has the usual push pop directory. So we can say that we want to push the site packages. I don't want to see all those. And we're going to push that. So we have pushed that onto the directory stack and changed to that directory. And we can push one more. There's a reason for this. Hit tab completion there. To the Zope B trees. Certainly Zope is one of the more complicated directory structures for large frameworks. I tap the dirs command, which shows me the stack, the pushdown stack of directories. And here we see I have the 2 entries. And that, hey, looks like a Python list too. So we can, and then there's the pop. Okay, so we can also bookmark our current directory. So we've changed the B tree Zope, and maybe we're going to be moving around the Zope framework here, and it has, probably 50, 75 directories, and it can be really tedious to do that. So let's just call this the B tree. Give it a nickname. We'll call it the B tree. And that marks the current directory. And maybe we want to bookmark another one here, which is the site packages. I need to go there a lot, maybe. So I'm going to do site packages, and we'll bookmark that. So we have 2 short names, and maybe we want to see what those look like. I hit tab complete here, and it put the % character on it for me for completeness. And here is some bookmarks. Got a BT left over from a previous session. Sorry about that. But we have that. So what can we do with bookmarks? Well, I can see. Remember where I am. I am in the B tree directory. Okay, so I want to go to the site packages directory to take a look at something. Okay, well I just CD to the name of the bookmark. I didn't have to specify relative to anything. Just take me to the bookmark. And of course it's there. I'm now in the site packages. Or I can change back to the B tree. So these can be very useful, and bookmarks can be stored out there persistently, as you saw the BT one. So for certain, and these are per project or per directory if you want, or per user account. So you could set up for a particular project several of the bookmarks to the places you tend to go to. And then we can, don't forget our directory stack had these 2 things on it, so we can hit pop D. Nothing special there. And maybe we want to keep it. Want to see what the history of where I've been lately. So we have a dhist, a directory history. So we can do that and see the places we've been. Now maybe there was something here, that temp directory over there, and I want to go back to that. So I can say CD to 1. Error. So let's take the CD question mark to find out what I did wrong here. And we see that. It has many different options here. Dash takes you back to the last visited directory, like the bash. I need to put a dash on the front of it, I see. So I can say CD to /-1, and I'm back in the temp directory. And so that's another way to move around without having to give them names. So now that we can move around the directories and we can look up information about objects, what's the next thing? Maybe, well, if we can change directories, it sure would be nice to be able to do system commands. The CD is a magic command, but let's talk about system as in commands that get issued to the underlying shell. The bang character is long time been an escape character to get to the shell in programs. So we can type exclamation or bang ls, and we run the ls command. And maybe we'll want more detail, so ls-l, and gives it to us with the time and sizes and such. That's good. And let's go a little further. So say we wanted to look at, let's go back to the site directory, so we have some Python programs in there to look at. And we can do a directory, and we see that the site packages, of course, has lots of files in there, including the PYCs and the PYOs. And programmatically, we'd like to look at certain ones. So we want to look at the .pys. We can put that on the command line, but this way our command can actually draw from our namespace. So we hit, have this variable pattern, and we still issue the -l, but we put $PATT. So this way, the $ says substitute the Python variable into the system command. So we see that only the .py files here. We can also put full expressions in those commands. So we can still use the $sign, but because it's an expression, we use the braces or squiggly brackets. So we still take that pattern, but we add to it a C. So we want to look at the asterisk.pyc files. And we do that, and as we see here, we see the pyc files. Now this can be a little tedious to using the bang to go to commands. You'd like to have, again, like bookmarks, you'd like to have a short way to give them names. These are called aliases. Aliases relate to the system shell commands. So we hit alias to find out what aliases come with IPython. And we see here that they give us cat, clear, less, make directory, remove directory, copy. The ones we've been seeing. So, oh, geez, ls is actually already defined. So I can just say ls without the bang because it's an alias. And seal those same kind of files as if I was doing. It saves me one character, the bang. That's not. And they thankfully have defined other options for us. LF for only list files. Things like that. You could find your own aliases. Like elder shows you only directories and the site packages here. That's just an alias. Nothing special related to IPython. So you wanted to find your own alias. That's good. So we define PR, and it's going to echo. You said %s. So we're going to aliases can have arguments. So we can say that. So now we now have an alias that says takes an argument. You said hello. We type alias, and we see PR down here is defined as we would expect. So it's easy to define new ones. And of course there's an unalias command, so we can take out what we did. Aliases don't persist across sessions unless you set it up that way. So another interesting thing, maybe these shell commands are nice, but sometimes you need to do more complex operations. Like, let's define a function go that takes a pattern. But inside the Python code, we're going to do it ls-l with the bang character, and the pattern with the $sign substitution. So the default pattern is going to be the pattern in the namespace here, which I still have there. Okay, so we have this function go. So we type go, and sure enough, does the asterisk.py using the. So we can actually call functions this way, and we can pass in a different argument to pick up .so files or shared libraries. So we do that, and yeah, sure, Seepaste has several of the .so files around. So we can sort of write programs around our system commands, turning them into sort of a Python-based batch files. Now, the output of this command, of course, went to the screen, but sometimes you'd like to see that as a variable. So we can say, okay, do the ls, and let's store this to a Python variable. And it returns a list. Now, the list printed out, whenever you do operations, just the same as typing a variable name in the regular interpreter shell, it prints out the operation. But x is still there, so we can say, okay, length of x, how many names did it return? Okay, 232 names. No wonder it scrolled off. We can also see this as, we can just type x. Okay, we see all the names. We can also see it as one string by putting a .s on it. This is a smart list, not a traditional one. So here it shows up as one string with space separation. And maybe we wanted to see it with, instead of one per line, with new lines between there. So we get back a new lines. Sorry, a list. L is a list. And N is new line. So here we see the list with the directory, the output of that command with new line characters. And we can also use pipes. So we can bring stuff together. So we say, okay, we want the py stuff, but we're doing the bang, ls, yeah, all that. And we're going to pipe it to the sort because we want an alphabetical listing of these files. So I hit return, and we get the same variables. But now they're all in sorted order, as you'll notice. So you can construct up more complicated scenarios here. Okay, running Python programs, of course, is all very nice playing system commands, but we are Python programmers. So let's go over here to where the presentations are and run a calculation program. Prints 5. not much fun. Let's take a look at calc here. So we can type less and hit the calc. We don't have to put .py on it. It will look the namespace up and find out that there's a file up there by that name. All right, there we go. Sorry. Okay, so calc is simply a file in a directory, and it's a very simple calculator object with an error message, sum and a divide operation, return the sum or return the difference, the quotient. We create a calculator, we divide 10 by 2, and it prints 5. Now, why is this interesting? Okay, notice here that C is a calculator, and we then did an operation on it. We ran this program inside of IPython, and it finished after printing the 5. But the C right here is now in our namespace. So after the program ran, the variables that it created, the modules it imported, sys and re, is available to us here at the shell. And let's make it easy, put the who's on there so we can see the types. So we see the calculator object, we see the modules that were imported, so we can get a view of the namespace. Now, each time we run calc here, it starts with an empty namespace. But there are options that you can pass to run. Run has a lot of options that let it inherit the current namespace. So you could set up the namespace, call your program, and it would take its variables from whatever you've interactively defined. The other thing to note is the if underbar name underbar equal main, then it calls this function. So when we did the run, IPython actually told it the name was underbar main, so it would run it. But there may be times, however, when you may have a module that defines classes and functions, but you don't really want to run it as a main. You want to just run through the source file, make the definitions, and then come back so I can call them interactively, say. And said run has options for doing that. I don't remember that, but anyway, it can do main or it cannot do main. Okay, you can also pass in P for profiling, which we're going to get to more details, but just briefly, you can do that, get profiling information, and you can also run your program with a -D under the debugger. And we're in the debugger running our program. We'll get into more of that. Now, you notice all the way here that we've each prompt has been numbered. That's the input history caching. It's keeping record of everything we've typed in here, and we can use Control P, Control N for previous to go back through things. Normal read line functions like that, and we also have the arrow keys that will do the same thing. No surprises there. And we can also type in part of something and hit previous, and it will take us back through all lines in our input history that started with DEF. So it can be useful when you're like, okay, I defined something. Where was that? I don't want to see all my history. Just let me go through all the definitions here. And Control C because I don't want to change things. The last command can be found with _I. And _II was 2 commands back. _II is 3 commands back. There's no 4i. You can also reference the previous history with an I and a integer. So we can go look at what was the number 1 command that we had, that we entered. And it was where we defined message flag equal 1, way back at the beginning there. And there's also a global variable where you can do subscripting here, so you could actually write programs that manipulate your input. So we can say what was the 3rd command, 0 to 3, and see that it was the definition of hello. So anyway, it's a list. You can also take a look at the history, hist command or history command, either one. And so we can do history, and it shows us the last 20 or so histories here. It doesn't show all of them necessarily, but you can see all of them, so we can say, well, show us the first through the 10th history item. So in the beginning of our session here, we see commands 1 through 9, because like a range in Python, it goes up from the first number up to but not including the second number. So we can see that. You'll see these underbar IP magic. Now that's because we entered magic commands, and that is the Python code that invokes the magic commands. And you usually see that, but if you want to, you can put the hist of R on there, and this will hide the magic commands. So we can actually hide the wrappers around them, and so we can actually see them as they literally got typed in. The benefit of not raw is that this lets you cut and paste these commands straight into your Python source and use them that way. You also can see the last 10 commands. Whenever the number is, it doesn't matter, just the last one number says the last n number. You can also replay them. So let's see, back up at the beginning, we had message equal hello. So if we delete message, not defined, we cleared it, that's right. So it was number 3, so we can just execute number 3. And now we see that message is defined as hello. So we can use the exec to with the underscore to execute any of those. You can also execute ranges, because it's a list. So we can execute the first through, the 4th ones are there. And it quietly takes care of that. Puts our variables back there that we deleted. Now, if you're using these often, then you might want to give them a name, because remember here we were setting up the variables here in the beginning, 1 through 4 was setting up initial variables, and maybe we want to be able to have a command that sets those up easily. So let's give them a name and call it begin, and we're going to say that it's lines 1 through 4, and also line 5, which just prints out message flag. So you can actually specify ranges with dashes, and otherwise just space and line numbers. So we put that together into a macro, and it executes the macro definition. So then we can just type in begin, and it defined those variables and also did the print of message flag there. Begin, of course, is an object in our namespace, so we can type begin 1 question mark. It tells us that it's a macro. We can print begin, which actually the source is up here as well, the string form of it, right there. But we can print it, and we can store that macro into our profile. Remember the store command back at the beginning. So we store begin, and hey, next time I start the session, that macro will be there waiting for me. So I can very quickly set up scenarios. All right, viewing and editing source. And let's just go to a temp directory here and edit an object that does not exist. So I edit ABC. What does this do? Takes me into Emacs. And I left these variables around. Let's exit back out and go with DEFs. .py. So we go in here and it brings up the def.py file, and we can set it to, see, green eagle. Let's give it some code, and we're in Emacs here. Save it out, and we exit, and we type in whose, and we see here that we have a blue and a green. Let me reset the namespace here, because this is a nuisance. Okay, namespace is empty. Now, what about that file there? When we do an ls, and we see that, there it is, def.py, and we can run def. Type who, blue and green are there. with their values. So certainly we can edit files, any file. Just put the .py on it, and as you change directories, you edit files. Nothing special. But we can also, if you recall, from the beginning, we had those those lines at the beginning. Remember, so we can actually edit lines of input. So we had 1 through 4 and line 6, I think it was. Actually, I better make sure. So we want to edit, looking up here, 1 through 3, let's say, and 5. Edit those lines. So we just hit the line numbers. Takes us into Emacs. There's those lines that we typed in as commands. So let's change this to hello world, and not print, it echoes it anyway. Let's change it to give us the value of pi. And let's change pi to some actual real numbers here. Okay, so we edited our input history. We return. We type in whos, and sure enough, it's redefined pi and executed the command. So we can edit our history. We also have the save. So maybe we've done some history work, and we say, you know, that was a really good test, or some work I was creating interactively. So I want to save that to a file. Let's say call Apple, and 1-3. Same syntax. Range of lines or list of lines. So I can save that out. And let's see what that was. Apple pie. So we cat it out, and sure enough, this file contains these definitions, these assignments. So we can save our history out in pieces at when we come up with good arrangements. Okay. We go back to the site, the bookmark, remember. And let's take a look at the site.py file, the less command. And as you see, it's Python source, but you know, and we can page through it. That's nice, but I like colors. So the pycat command is a cat concatenate view source kind of a thing for Python specifically. So, but it does syntax coloring. So we'll do the same thing. And hey, now we have color on our Python. Yeah, small thing, but the little thing that IPython does for us. And let's see, we did the editing of objects was as a nice one. So as we defined function ABC, prints the values, you know, same as before. Then we want to edit that, so we say, you know, let's just edit the XYZ function. I don't know what file it is, but let's we can edit 163. I163. There we go. So now we can go in and play with the function here and exit, and it brings it back into our namespace. Print XYZ. Okay, you know, it's a function. Oh yeah, the source of XYZ, p source, and we can see that the change is now in our namespace. Okay, no big deal. Now, there's another command called Seepaste to paste code in. Now, you'll notice that as we were typing the definition there, that IPython was automatically indenting our source and you know, putting little dots up there and you know, interacting with us. But sometimes if you want to cut and paste from a website or from another place some source, you really don't want IPython interfering with your paste operation, your multi-line paste. So there's a Seepaste command which puts it into an input mode, waiting for a -- alone on the line. So it's waiting for us here. We pop over to the Python cookbook, And let's see here, let's go to the algorithm section. Pop over there, scroll down, let's find us a nice one here. Pythonic implementation of xrange that works not just on integers but floats and other data types. Sounds interesting, so we go to that. As it loads up. And there's the source there, looking it over, and yeah, I'd like to play with that. So let me just pop over here to the text source, cut and paste it here out of the browser. Scroll that back up here, and oh yeah, IPython's waiting here with the Seepaste command. So I'm just going to paste that in, hit the dash dash to end it, and the code's there. So I can type in the who and see that we now have an xrange over here. Right there. So now I can play with this and say, okay, went from 1.0 to 5.0 in increments of 0.1. Give me a range, and oh yeah, this is, I don't want an iterator, I want a list. So let's actually see the values. And there you go. So we can very easily cut algorithms off of other places and get them into IPython quickly. The other thing it does, IPython does, of course, is output caching. The results of these commands is it's been keeping track of, and one place it stores them is a variable called out. It's a dictionary. Now, not all commands result in output. Some of them just simply operate and return nothing or none. So let's take a look at the keys for the out array, the history. Okay, so all of these commands actually have some output associated with them. So we can say out, what was the output for command 118? _I. Let's try to find something more interesting here. Message equal hello. So you can anyway, you can operate on the outputs because it's just a dictionary. So we can concatenate to it outputs message equal hello with a semicolon 34 on the end of it. Now, let's see. Another thing to be aware of is if you wanted to call a function that returns something. Let's see. Give me a moment here to navigate down to my demo files. That wasn't it. That's just to find one. Could have sworn I had one, but print AB, return hello. Okay. I call it. It prints it. It also prints the return value of hello. Maybe there's a function I want to do where I say execute this thing, but I really don't want to see the return value. It's either very long or just something I don't want to. I'm not really interested in. You can finish your input with a semicolon, which says call this function and discard the return value. So here I just see the print of the A and B, but I don't see the return hello. Small thing. The log files. I don't know where I left that running. There's a log. Here is the result of our session so far. Just to return to it, just to let you know that I'm paging through the log here. It's keeping a quite detailed record. Now, one of the things you can do is you can also say run log in the name of one of these log files. You could have multiple log files, maybe other sessions you've saved and all. And it basically will go back through and execute each of those inputs. Now I'm not going to do it here because it'll mess up the demonstration, but you can actually re-execute your log files to put you back into a certain state. And it executes each of those inputs inside a try except, so that if there was an error, say you were experimenting and it messed up, it won't stop the execution. It'll just go on past those and bring you up to date on your current state. And debugging your programs. We talked about the debugger a little bit, but let's go into a little bit more detail on that. Now, when you have exceptions, we have the usual Python exception, but we have other choices as far as the appearance of them. So we have the exception mode and put it into plain mode. And we're going to run calc2. Okay, this program intentionally has a divide by 0, so we can see how exceptions are done. So this is the plain exception mode that gives us a 0 division error. Now we'll put it into a context mode, exception mode, and we'll run it again. And here it actually gives us a few lines of source code around each of the stack levels, so we can see, give us idea where we are here. And then the third mode is I've been doing too much BBSing, Xmodem there. Is the verbose mode. It'll look very similar to the last one, but you'll see a subtle difference. Let's see if you can find it. See, it still gives us the context. The difference is right here, for example, is it tells you what the arguments that were going into this function. So it gives you, without having to query the values of operations, it'll actually tell you what the call values were for each of the operations going in. Another function is PDB, which turns on the automatic calling of PDB upon the occurrence of an uncaught exception. So we can run that calc2 again, and notice the prompt over here when I hit return. We're in IPython here. I run that calc. It hits the exception inside my program and drops me into the normal Python debugger, the PDB, so that I could dig into the situation. I hit Q to get out of the debugger back into IPython. Okay, you can also run inside the debugger, so say run-d and calc2. The difference here is it starts at the beginning, and it drops you in the debugger at the beginning of the program calc2. So you have all your usual continue or whatever options you want, so you can single step through and still get the exception, and then it comes out of the debugger when the program finishes. And of course, you may also want to say, just in my current namespace, just take me into debugger now. There's something I need to look at. So you hit debug, poof, you're now in PDB. So you can go in there when you have an uncaught exception. You can run your program inside it from the very beginning, or you can go into the debugger explicitly. Get out of PDB. There is another option for helping you debug. Oops, not Emacs. We're going to edit the calc2 program. Same as the other calc program, except that this divides by 0 instead of dividing by 2. Now, you'll notice these lines right there. Now, those 3 lines cause your program, when run, to bring up the IPython shell and bring you into it at that point in execution. And you can do whatever you want. You have full access to the namespace. And then whenever you exit the shell, it will continue running your program with that line that we do the division by. So we would uncomment that. Just a moment. We have a permissions error, but I will fix it. back into IPython. Okay, now we've uncommented that. So now when we run calc2, now we're in IPython running calc2, it will take us into a subshell of IPython. That'll look very different. But the difference is in the namespace. We now see the A and the B that are about to be divided. And we see some IPython variables. So we can actually see the A and the B and be able to interact with the system call. This is not just for debugging, but also useful for long-term calculations where you want to run some parallel computing process or something and let it run for long minutes or hours, and then you want to want it to stop afterwards so you can query and explore the data that it's returned. And here I just got back out of the IPython. The difference here also is when you're in IPython, you're not single stepping. You're not really in the debugger. You're simply back into the IPython shell. So it's less disruptive to your running time environment because it's just like letting you peek in the system and then continue running. Now another thing IPython does is profiling. It's close to debugging, but a little different. So you can use the time command. These are functions already built into the library, but IPython gives you access to it. So we can sum up, get a range of 10 million numbers and time how long it takes. And it takes 3 seconds here. We get user time and system time, just like it's your normal shell. That gives a coarse measurement of time. If you were going to time something that was very short, like 1,000 of those, it's done in 0 user seconds, 0 system seconds. Basically, it gives you no useful information. You don't know how long that really took. So we have the timeIt command, also part of the standard library. So we can put in something very short like this. Now, timeIt will actually run it multiple times. It'll automatically adjust itself to it'll run one loop, compute how long it takes, and then set up a number of iterations. So here we find out that it takes 128 microseconds per loop. So we can measure very small things, very fine resolution. Okay, so we have going on with profiling. Let's take a look at something a little longer. So let's take a look at Walker. Now, Walker's little program I just threw together from the cookbook that walks a directory tree looking for files of a certain pattern and returning those. And there's a function here called zopdocs. So especially when I walk the entire zope directory tree and find me all of the .txt files and return a list of those files. Okay, it'll take a little while to do that, of course. So let's run Walker. It'll take a moment here. Shouldn't take very long because when last time I ran it, it was very quick. There we go. Okay. So we have all those text files. So we now have the zopdocs function here is now defined in our namespace. So we can time zopdocs faster because the directory entries have been cached. And at the top, I'm paging up. Well, as you see, it's very hard to find things inside that. So remember that semicolon command that says, hey, run this thing but don't show me the output? We can put the semicolon on the end of that. So here we actually get the time. Find out 0.21 seconds, and so it's not very long. But the semicolon lets us, run the command without seeing the output, and time lets us see the course level. But we also have the timeIt. So it's going to multiple walk that directory tree. We don't need a semicolon because timeIt never prints the output. Time does. So we run timeIt and get a more averaged runtime. Takes a few seconds, but not very long. There we go. So 320 milliseconds for each directory tree walk. That's the so we get a course and we have a find. We also say you want more detail, so we can say, okay, prun. Now prun runs expressions. It does not run files, but it runs the Python profiler system with all the documentation already you'll find elsewhere. So we run prun on that directory tree walk, and it brings us back in here with per call, per time, which function was it in. So this gives you a lot more detail for profiling. And then yet another way to run your program is run-p with Walker. Now this is the reverse of prun. Prun runs expressions, not files. Run-p runs files, not expressions. So we'll run that into the profiler. We'll get basically the same output, it's just that it came from a different place. And we'll see the output. Okay, no big deal. Now we have another file called GoFetch. Now we're going to what this is going to look at is running things in the background. IPython lets you start long-running operations in the background. These operations are Python expressions. They're not separate files because you could use that. You could use a system shell for running whole programs in the background, but this lets you run actually expressions in the background. So, GoFetch.py is a little program that goes to the python.org site, opens a connection, reads in the page, closes it, and returns the data. It won't take very long, but it will take a pause. So we run the bg command. So we say run. Let's see. Actually, let me bring it into memory here. Actually, this is how it's going to be looking at it. So you see that. And when we get done, it's GoFetch is now in our namespace here. Right there. So let's run GoFetch in the background. Poof. Job number 0 is now running in a separate thread. We can continue doing other things in our life. And sometimes we say, hey, whatever happened to that job number 0? So we can type job 0 status. It's finished. Remember, it returned the HTML page, so it's going to be a lot of data. So we say, okay, show us the result of that operation we did in the background. And here, as you see, it shows us the HTML from the main Python page. Alright, we're almost done. It's been a long session, I know, but IPython is very feature-rich, and I just wanted to give you, show you a lot of the things it can do. This is most of what it can do. One of the things it can do is input filtering. I won't go into detail how to create those yourself. That's a little bit magic. It is documented. But this is what I mean. Let's write a domain-specific language. So first of all, let's exit IPython. Get all the way out here. Okay, we're back at our shell. Clear the screen. Back at the shell. So we run IPython, and we pass it another option, -p for profile. We're going to load the physics profile. Now this adds extra input filtering to what we type. I can type physics. Okay. Brings it up. Not much different. A few things have been defined at the top, but we're inside there. Now, suppose you had a mass, and it was 200 pounds. Notice we'll add units here. And the velocity, it's traveling at 30 miles per hour. Now, you've never seen Python code that lets you put units straight into your source like this. But the input filtering system lets you do that. So we have a mass, we have a velocity. And we can compute the kinetic energy using an equation that's perhaps familiar. Half mv squared. So we compute it, we type the energy, we get an answer, but we also get correct units with the output. Of course, pounds and miles, not very metric. So E is stored in pounds and miles. Let's convert that to unit. Hit tab complete to find out what that is. And we'll convert it to joules. Now, I know that joules is a capital J, standard notation. So we hit return, nothing displays. It doesn't convert it and print it, it converts it internally. So E is now measured in joules. So E, what are you? Oh yeah, 8,000 joules. That's what happened when this the kinetic energy that it had moving at that velocity. Anyway, that's units. Now the other thing is we're always playing with text here, and IPython actually plays well with graphical frameworks. It has another profile, another option, Pylab. Takes a little bit longer because it loads in some scientific options here. This it hooks us into a matplotlib-based Python environment. Has its own little. You get more help about that. Now, briefly, they need a whole talk on matplotlib, but we go back to our Python's our browser. Let's go to the matplotlib site. Okay, so these are screenshots. It shows you the diagram and it shows you the source that generated this. Okay, well, yeah, this graph looks nice, so let's just go over here and grab this source right here. You'll notice it's not a lot of source, but I'm not going to explain all the code right now. That's another talk. And go back into IPython, and we type that Seepaste command, and we paste that code. And there we go. We actually get to see that that graph there. And I will close the window. And got lots of variables here now, so let's just clear out the variables here. And let's just do one other just for fun. What would be interesting? The bar chart demo. So we pop over there, we grab all this source, get out of the way, paste it in, poof, and we have our bar charts. And we have the source here to actually play with it. And we have the history. Anyway, that's the data visualization. As you see, it plays well with the graphics. It also hooks into WX Windows, and there's a variety of others it hooks into. So that about covers everything here. If you think IPython is interesting, for more information here, pop over to the IPython SciPy website. It has some good documentation. And if you have any questions or comments on this presentation, you can contact me at this email address. Thank you for listening, and I hope this talk wasn't too long.